Hello, and welcome to the next video of Section 1, Event and Callbacks, Adding Life to Programs. In the previous video, we have learned about tkinter Geometry Manager. In this video, we'll learn how to call back a specific widget using the command binding rules. Now that you've learned how to add widgets to a screen and position them where you want, let's turn our attention to the third component of GUI programming. This addresses the question of how to make widgets functional. Making widgets functional involves making them responsive to events such as the pressing of buttons, the pressing of keys on a keyboard, mouse clicks, and the like. This requires associating callbacks with specific events. Callbacks are normally associated with specific widget events using the command binding rules, which is discussed in the following section. Command binding. The simplest way to add functionality to a button is called command binding, whereby a callback function is mentioned in the form of command equals sum underscore callbacken the widget option. Note that the command option is available only for a few selected widgets. Take a look at the following sample code. After defining the above callback, we can connect it to, say, a button with the command option referring to the callback as follows. A callback is a function memory reference that is called by another function, which takes the first function as a parameter. Put simply, a callback is a function that you provide to another function so that it can call it. Note that my underscore callback is passed without parentheses from within the widget command option, because when the callback functions are set, it is necessary to pass a reference to a function rather than actually call it. If you add parentheses like you do for any normal function, it would be called as soon as the program runs. In contrast, the callback is called only when an event occurs. Passing arguments to callbacks. If a callback does not take any argument, it can be handled with a simple function, such as the one shown in the preceding code. However, if a callback needs to take arguments, we can use the lambda function, as shown in the following code snippet. Then, somewhere else in the code, we define a button with a command callback that takes some arguments, as follows. Python borrows syntax from functional programming called the lambda function. The lambda function lets you define a single-line, nameless function on the fly. The format for using lambda is as follows. Here's an example. Now, we can call the square method as follows. Limitations of the command option. The command option that is available with the button widget and a few other widgets is a function that can make the programming of a click of a button event easy. Many other widgets do not provide an equivalent command binding option. By default, the command button binds to the left click and the space bar. It does not bind to the return key. Therefore, if you bind a button by using the command function, it will react to the space bar and not the return key. This is counterintuitive for many users. What's worse is that you cannot change the binding of the command function easily. The moral is that the command binding, though a very handy tool, is not flexible enough when it comes to deciding your own bindings. Event binding. Fortunately, tkinter provides an alternative form of an event binding mechanism called bind to let you deal with different events. The standard syntax used to bind an event is as follows. When an event corresponding to the event description occurs in the widget, it calls not only the associated handler that passes an instance of the event object as the argument, but also the details of the event. If there already exists a binding for that event for this widget, the old callback is usually replaced with the new handler. But you can trigger both the callbacks by passing add equals plus as the last argument. Let's look at an example of the bind method. This is a description of the preceding code. We bind the frame widget to the button 1 event, which corresponds to the left click. When this event occurs, it calls the callback function, passing an object instance as its argument. We define the callback event function. Note that it takes the event object generated by the event as an argument. We inspect the event object by using dir event, which returns a sorted list of attribute names for the event object passed to it. This prints the following list. From the attributes listed generated by the object, we use two attributes, event.x, and event.y to print the coordinates of the point of click. When you run this code, it produces a window as showing here. When you left-click anywhere in the yellow-colored frame within the root window, it outputs messages to the console. Event patterns. In the previous example, you learned how to use the Button 1 event to denote a left click. This is a built-in pattern in TK-Enter that maps it to a left-click event. TK-Enter has an exhaustive mapping scheme that perfectly identifies events, such as this one. In general, the mapping pattern takes the following form. Typically, an event pattern will comprise the following. An event type. Some common event types include button, button release, key press, focus in, focus out, leave, and mouse wheel. For a complete list of event types, refer to the Event Types section at this site. An event modifier. Some common event modifiers include Alt, any control, double, lock, and shift. For a complete list of event modifiers, refer to the Event Modifiers section at this site. The event detail. The mouse event detail is captured by the number 1 for a left click and the number 2 for a right click. Similarly, each key press on the keyboard is either represented by the key letter itself or by using a key symbol abbreviated as keysim. For example, the up arrow key on the keyboard is represented by the keysim value of kp_up. For a complete keysim mapping, refer to this site. Let's take a look at a practical example of the event binding on widgets. The following is a modified snippet of code. It will give you an idea of the commonly used event bindings. Rather than binding an event to a particular widget, you can also bind it to the top level window. The syntax remains the same, except that now you call it on the root instance of the root window, like root.bind. The levels of binding. In the previous section, you had a look at how to bind an event to an instance of a widget. This can be called an instance level binding. However, there may be times when you need to bind events to an entire application. At times, you may want to bind an event to a particular class of widget. TK-Enter provides the following levels of binding options for this. Application level binding. Application-level bindings let you use the same binding across all windows and widgets of an application as long as any one window of the application is in focus. The syntax for application-level bindings is as follows. The typical usage pattern is as follows. An application-level binding here means that irrespective of the widget that is currently under focus, pressing the F1 key will always trigger the show_help callback as long as the application is in focus. Class level binding. You can also bind events at a particular class level. This is normally used to set the same behavior for all instances of a particular widget class. The syntax for class level binding is as follows. The typical usage pattern is as follows. In the preceding example, all the entry widgets will be bound to the Control V event, which will call a method named paste event. Event propagation. Most keyboard and mouse events occur at the operating system level. It propagates hierarchically upwards from the source of the event until it finds a window that has the corresponding binding. The event propagation does not stop there. It propagates itself upwards, looking for other bindings from other widgets until it reaches the root window. If it does not reach the root window and no bindings are discovered by it, the event is disregarded. Great! We've successfully learned about event callbacks adding life to programs. In the next video, we will learn how to handle widget-specific variables.